Hey guys, and welcome to 6.5. In this lesson, we're going to be talking about just a general overall factoring strategy because it's a kind of a hodgepodge of everything we've talked about thus far in Chapter 6. Okay, number one, you should notice that I can take out at least a 5. And because that first term is negative, I don't like when my first term is negative, so I'm going to go ahead and take a negative out when I take out the 5. Also, each term has an x, so let's do that. So let me take out negative 5x, and that's going to leave me with 3x, and because I took out the negative, that's going to be minus 5. So negative 5x times 3x minus 5, that's what I wanted. Number two, so on number one, all I did was take out GCF. On number two, I have a difference of two squares. So I'm going to take the square root of each term. The square root of the first term is 4x. Put it in both. The square root of 9 is 3. Put it in both, and I got one of each sign. Plus, minus. And there's my answer there. On number three, this kind of goes back to 6.1, where I have 4 different terms. I'm going to factor by grouping in this case. So I'm going to take the GCF twice. So on the first two terms, I have a 3 that I can take out. So it's going to be 3 times x plus y. On the second two, I'm going to pull out an x. So it's going to be plus x. And that's going to be x plus y on the inside. Because both terms now have an x plus y, I'm going to pull that out. And everything that had an x plus y, I'm going to put together. It's going to be 3 plus x. You could say x plus 3 if you wanted to, but that's going to be your answer right there. All right, number 4. I can take out a 4. I can take out an x. Let me start there. This is going to give me x squared minus 4. Well, the x squared minus 4 is the difference of two squares. So 4x, and binomial, x, x plus minus, that's going to be the factors of 4 are 2 and 2. Or the square root of 4 is 2 and 2. Right, and there's your answer there. So moving right along. All right, there's nothing new under the sun here. All right, we're just kind of taking everything we've learned and applying it. So on number 5, we're going to take out a 7. All right, so it's going to be x squared minus x minus 6. All right, when I do that, it's going to be x, because the second sign is negative, I got one of each sign. All right, and that's going to be 2 and 3. They give me the one in the middle, but because the middle term is negative, it's going to be a minus 3 and plus 2. And there you go. On 6, I'm going to pull out a 5, and that's going to give me x to the 4th minus 1. And remember, when your GCF is one of your terms, you replace it with 1 when you take it out. All right, so that's going to be the x to the 4th minus 1 is the difference of two squares. So that's going to be x squared plus 1, x squared minus 1. Now, x squared minus 1 is also a difference of two squares, so I have to keep factoring until there's nothing else I can touch. So this is going to be 5 times x squared plus 1, x squared, or x plus 1, x minus 1 is the breakdown of x squared minus 1. And so now I'm done. The x squared plus 1 is the sum of two squares, which means nothing to me. But you have to factor multiple times because I still have differences of square popping up. All right, on number 7, there's not a GCF that you can use. Also, the first term is a perfect square, but the last term is not. So now you're forced to do the AC method. Let's do that. This is going to be y squared plus 8y minus 84. So this is your list of factors of 84. I'm going to factor y. Second sign is negative, so it's going to be plus, minus. When both of my signs are different, you're essentially looking at your list of factors and say which ones are 8 units apart. That's going to be 6 and 14. Right, because 14 is bigger than 6, it's going to get the sign of the middle term, so it's going to be plus 14 minus 6. And then just like before, because I multiplied by 4 to begin with, I'm going to divide by 4. And yes, my denominator is not going to go away. So this is going to be 7 over 2. This is going to be y minus 3 over 2. So I still have denominators, so I'll kick them up. And that's going to result in 2y plus 7 and 2y minus 3. And that, after a little bit of work, is your answer. All right, once again, you have two squares on both ends on number 8. X squared is the perfect square, 100 is the perfect square. But I have to have a difference of two squares, not the sum of two squares. Okay, so because this is the sum of two squares, this can't be factored, and so it's prime. All right, on number 9, each term has at least y to the 4th, so I know I can pull that out. 5 goes in each term, so I can pull that out as well. So it's going to be 5y to the 4th out on the outside. It's going to leave me with y squared plus 4y plus 4. And now I factor the inside, or at least I try. So let's see. It's going to be y and y plus plus. So I can do 2 and 2. Okay, and because that's y plus 2, I can condense it further and say 5y to the 4th times y plus 2 all squared. Okay. Number 10. If you don't recognize it, you're going to have to do the AC method. And 36 times 25, it's big. It's 900. So this is one of those situations where if you remember that one of your formulas from 6.4, one of your special products, and if this is one of those, then you're going to have to do the AC method where when you multiply 36 times 25, you get 900, and you're going to have to figure it out because this will factor. So if you don't, you should be able to at least recognize that that first term and last term are perfect squares. So if that's the case, I'll do 6y and 6y because that's the square root of 36y squared. The square root of 25 is 5 and 5. Both sides are positive, so both sides are positive here. So that looks good. Let me test it. So the inside product is going to give me 30y. The outside product is also going to give me 30y. So that's going to give me 60y in the middle. So this works. So this is going to be 6y plus 5 all squared. Okay. Number 11. Again, I don't like that first term to be negative, so I'm going to take out at least a negative. It looks like 5 goes into all of my terms, so I'll take out 5 as well. Looks like there's also at least one y in all my terms, so I'll take that out. It's going to be negative 5y on the outside, and on the inside, it's going to be y squared. Because I took out the negative, it's going to be minus 11y plus 28. Okay, so negative 5y is going to hang out. Two binomials, y. Second sign is positive, so both sides are the same as the first sign, which is minus. Okay, and then 4 and 7 give you 28 and add to 11. Okay, nothing else to do there. That's completely factored. That's it. Okay, number 12. Here, you may not know that 6 goes into 486, but maybe you give it a shot. You may be able to also recognize that 6 goes into 48 and 6 goes into 6, so maybe it does go into 486. So these are just things that you can look for. So I can take out at least the 6. Both terms have at least one y, so I can take that out. And I can rewrite this as x to the 4th minus, that's going to be 81 y to the 4th. Okay, now that's the difference of two squares on the inside. So binomial, square root of each term, that's going to be x squared plus 9y squared, x squared minus 9y squared. Well, x squared minus 9y squared is the difference of two squares also. So once again, I have to do this one more time. X squared, the sum of two squares, I just bring down because it doesn't mean anything to me. All right, and then here, I'm going to have x plus 3y, x minus 3y. Okay, there's nothing new in this section. We're just taking everything that we've learned as far as factoring goes and applying it. So that was 6.5. I hope that was helpful. And if you have any questions, please reach out, and I'll see you in the next video.